Okay. So 8B.5, we are going to be analyzing statements about logs. So we're just going to be mostly looking at equivalent statements and how to rewrite logs and exponential functions to their equivalent statements. So a lot of it is going to be kind of review. So what I'm going to have you guys do first is give me an example of an exponential function and then write that exponential function as a log equation. I don't care what your exponential function is. So for example, 3 squared equals 9. That's an exponential function. Choose a different one, write it down, and then rewrite that as a log. So an example could be 7 to the third equals 343. You could have done something much simpler like 2 to the third equals 8. I don't care, just as long as you recognize that these are exponential functions. And then to write them as a log, remember your bases have to be the same. So in this example that I'm giving you, what is your base? 7. So this is going to be log base 7 of 343 equals what? Equals 3. So whatever your individual example was, just rewrite it as a log function. Okay? So these are what are called equivalent statements. Other examples of equivalent statements are 2 to the second equals 4 and 2 plus 2 equals 4. Those are equivalent because you end up with the same result. Okay? So an equivalent statement means that you end up with the same result. So our first example, I want to write an equivalent statement to 27 to the power of 1/3 equals 3. So in this case, an equivalent statement of this exponential would be a log. So an equivalent statement to an exponential would be a log. So the equivalent to this exponential would be log base 27 of what?
3.
Of 3 equals 1/3. Okay, so that's all we're doing is we're going back and forth writing equivalent statements. We have. So this time I'm going to have you guys do it with just variables, no numbers in there. What did you get for number 2? Log base x of y equals z.
X to the z equals y.
X to the z equals y. Thumbs up, yes? Okay. It could not be 3 squared equals 9 because we don't know what x, y, and z are yet.
One saying like x equals 3.
Yes. If I told you what to plug in, then yes. Okay, number 3, what log d equals g. What is your base on that one? 10. So this is going to be 10 to the what?
G.
10 to the g equals c. Make sure that you know that this is a 10, not a log. Okay. Any questions so far? Because there's no base written, so you can assume it's a 10. Number 4 is a multiple choice, and you are going to see questions like this, so I do want you to write out the whole problem, okay, including the multiple choice responses. So I'll give you a second to write it down. So, if you guys take a look at number 4, we have 2 to the power of log base 2 of x equals x. This is a special case, right?
Yeah.
Because my bases are the same, so what happens? So they cancel, and we end up with x equals x. Is that a true statement?
Yes.
Yes. So my initial thought would be the answer is A for all values of x. However, I gave you some rules about the number that we're taking the log of. Does anybody remember what they were?
It cannot be negative.
Cannot be negative. What else?
Yeah.
And it cannot equal 1. So, is this statement true for all values of x?
No.
No, not for negative. And not for 1. So what would our answer end up being? B for some values of x, not for all of them. Okay? I know, thank you. So you just have to make sure that you are paying attention. Just because we end up with x equals x, make sure that you are paying attention to the rules that I gave you about that number. Okay? Same thing about your base. Remember, your base can never be negative or 0, right? So, or 1, same thing. So you have to make sure that your statement works according to the rules that I gave you at the very beginning. Okay? Okay, equivalent statements, and then a graph, and then we're done. So number 5, what is an equivalent statement to log base 2 of 32 to the x? Normally, we would set the whole thing equal to x and then solve, but we already have an x in our problem. So I'm going to go a different route about this. Here I have a base of 2. can I rewrite 32 as a base of 2? Yeah, it's 2 to the what? 2 to the 5th. So let's rewrite this as log base 2 of 2 to the 5x. Does a special rule apply now? Yeah. My 2's end up dropping, so we end up with 5x. Equivalent statement. I don't know. I'm going to give you the exact same problem, just different numbers. In number 6, I want you to try it on your own. Okay, guys. If we don't have a base written, what actually is our base? 10. And so can we rewrite 100 as a base of 10? 10 to the square. So then our bases of 10 end up dropping, and what would our equivalent statement be? 2x. Not bad? Okay. Last one, and I do want you guys to write the problem too. So we're going to go back to these. If the equation of y equals, and this is 1/2 in parentheses, to the power of x, is graphed, which of the following values of x would produce a point closest to the x-axis? So we are going to graph this one and then look and see what point gives us our line closest to the x-axis. Okay, so whenever we have an exponential that we're trying to graph, the first thing we always do is we make a t-chart. And I'm always going to plug in those same numbers, 2, 1, 0, -1, -2. In this case, where am I plugging them in? For x or for y? For x. How do you know? Because that's your exponent. So this is 2, 1, 0, -1, -2. If I were to plug in 2 for x, what would I get for y? 1/4. What about 1? 1/2. 0 always gives me 1. -1 is going to give me what? 2. And -2, 4. Okay. So then we set up our x and y axis. 1, 2, 3, 4. 1, 2, 3, 4. Is good enough. Okay. 2, 1/4. So that's going to be right 2, and 1/4 is halfway between 1 and 1/2. So it's just over the x-axis. 1, 1/2. So we're going to go right 1 and then up half a step. 0, 1. -1, +2. So left 1 and up 2. And then -2, +4. So on mine, it's going to go all the way to the top. Is this an increasing or decreasing exponential? Decreasing. So let's think about it. As my graph is getting closer to the x-axis, am I going to the right or the left? To the right. Are my x's getting bigger or smaller as I go to the right? My x's, guys. Bigger, right? Because on the number lines, the x's get bigger to the right. So of these 3 choices, which one is the biggest? C. 5/4 is 1 1/4. So C is the biggest. Okay, so the further I go along the x-axis, the closer and closer my line gets to the x-axis. So I want the biggest x possible. Okay.